our review package for our conics and transformations. Now, Mr. Wah dropped in as I was partway through recording the video solution to number 3, and I thought the pause button would pause recording, but in fact it just paused the image and recorded everything we said for the next half hour. So I'm learning to edit videos so that first video isn't going to waste, and so I apologize for having to just finish off here the last part of 3 in 2 separate videos. That's a little unfortunate. So we were most of the way through transforming f of x into this new function here, f of negative 3f, pardon me, y is negative 3f of half of x plus 6. And so the last thing we have to do is we have to transform it to the left 6 units. Now, it may be overkill to think about each point so formally with such a trivial operation as a translation. However, we started down this road, we're going to finish down it, so it looks like we are going to take each of our x values and subtract 6 from them to represent this negative 6h here. That's going to take my negative 4x value and take it to negative 10. Negative 4 take away 6 is negative 10. Negative 2 take away 6, negative 8. Then we have 0. Okay, that's easy. So negative 6 and then 9. Again, these y values are not changing. I could even have just written all the y values. And that's 4 take away 6. That's negative 2. So that means we have 4 new points to plot. And these are our last final 4 points. Negative 10 and positive 6. Negative 10, positive 6. Negative 8, positive 6 goes to negative 8. Oop, wait. Yeah, negative 8, positive 6. It's here. And then we have 6, negative 9. So it's going to negative 6, negative 6, 9. So we'll move to negative 6. Go up to 5, then 6, 7, 8, 9. All 9 there. And the point negative 2 and negative 3. Negative 2, negative 3. And those are our final points. So these ones, first I will code that with green because that is our green transformation of shifting 6 units left. And I'm going to use highlighters to indicate that as my final shape. And we're going to use a solid line to connect these as well because this is our real final transformed image of the function f of x. And I'll even write a little thing here, solution. Okay. So once again, I apologize for having to split that into 2 videos. It's a little inconvenient for you, I recognize. So let's move on to question 4. Alright, we have this function, and rather than it being a general function f, it's a specific function, which is an absolute value function, and is transformed in the following ways. Alright, we have a horizontal dilation by a factor of 5/4, a vertical dilation by a factor of 5, reflection over the x-axis, a translation 111 units upward, and a translation 9.13 units to the right. And we're going to write the transform function. So we have to write something in the form y equals a f of, oops, got carried away there, what goes there? B, x take away not c but h, plus k. So as long as we can find the values for each of these numbers, letters, which is a, b, h, and k, we should be able to write a new formula over here. Alright, so let's go through and let's see what all of our letters would be. So we have a horizontal dilation. Okay, so horizontal transformations exist within these set of brackets. And in this case, a dilation is going to be A or B, so that means it's going to be our value for B. So we have a horizontal dilation, so that's like this guy here. And it's a factor of 5/4. It's a stretch, which means our B value is the reciprocal of the stretch. So that means B is 4/5. All right. And I'm going to maybe I'll put a little yellow around that. And then we have a vertical dilation by a factor of 5. So I'm going to make that my A value here. Vertical dilation. And that, pretty straightforward, that means our A value is equal to 5. Reflection over the x-axis. Now, counterintuitively, if you reflect over the x-axis, that despite the fact that we talk about the x-axis, that is a vertical, it manipulates the y values, and so that's going to be on the outside of the function f of x. That's going to manipulate this a value here. So that's going to contribute to the value -5. So that's a part of our a value here. Alright, and we have a vertical translation, 111 units up. I think my translations were good. I only have 3 highlighter colors here, but I think translations are probably getting pretty comfortable at this stage, so I'm going to code them with the same color. So we have a translation vertically, 11 units up, and horizontal translation, 9.13 units to the right. And so what that means is that our up, that's our k value, k is 111, and our h value, we're moving to the right, so that means our h value is 9.13. Okay, I'll code these guys in here as well. Now, that means our y value, or pardon me, our new transform function is y is equal to, well, start by writing a. So it's going to become -5. That's our pink value here. And rather than use our general function f, I'm going to be using my absolute value symbol. That's our specific function. In this case, it takes x's and gives you the positive value of them. Other than that, everything else is pretty much the same. I'm going to write our b value of 4/5, and that's going to be in yellow. Which barely shows up in the video at all. Maybe I'll extra yellowify that. And then I've got inside this bracket, I've got an x, and I'm going to be taking away my value for h, which is 9.13. That's one of our green values here. And lastly, we're going to be adding 111 to the outside. And that's our final answer. Okay, so now we're asked to write the equation of a transformed graph, just like we were asked to do here. And the difference is that rather being given specific transformations, we're going to have to infer what transformations are occurring by just taking a look at how this shape has been manipulated. Now, we have this rule of thumb, right? DRT, don't reuse toilet paper, so dilations, then reflections, then translations. So I'm going to start by looking at dilations. Because A comes first, I usually think of my vertical ones first. So the first thing I would do is I would take a look and I would say this one seems to be vertically, has about a height of 3 units. And this function seems to be taller, but I'm not sure how much taller. But I can see, looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It has a height of 9. So it looks like it's been stretched horizontally by a factor of 3. A is 3. I can tell it's 3 because I've multiplied these y values by 3 to get all the way down to 9. Alright, now I'm going to come back. It may turn out that that a value is negative in the reflections section, but I'm going to stick to trying to think about dilations first. So then I'm going to take a look at my horizontal dilations. Has it been stretched or compressed? I don't think it really looks like it does, but I'm going to count it anyway. So it looks like I start here and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 12 units long there. And maybe I'll write that up here to emphasize that it is 12 units long. And across here, it looks like I'd start here and I'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is another 12 units. Okay, so it looks like this has not been horizontally stretched or compressed. So our b value is just 1, and we're multiplying those b values by 1. It's not 0, because then you'd be multiplying by 0, and that would really make your graph not very interesting at all. All right, let's move on to reflections. Dilations are finished. Reflections. So it looks like this one has been reflected at least once over the axis here. That's a reflection over the x. So if you do a reflection over the x-axis, that makes your a value actually negative as a result. And but that's not all. It looks like there's more things going on here. It looks like in addition it was also reflected over the y-axis somehow. And so that means in addition our b value is negative 1. Okay. Now we should move on. That's our reflections, 2 reflections in this case. And move on to translations. Well, if you stretch this thing, flip it, and then flip it again, looks like it would probably look something like this, more or less. I kind of sketched that really roughly, and that's okay. What I need to know is that it looks like, in addition, it doesn't look like it was moved up or down, but it does look like it was shifted to the left. And by left, I mean right, plus 5 units to the right. So that's going to be my h value, and that's going to be 5, moving 5 units to the right. It looks like the k value was 0. Nothing was shifted up or down. So I'm going to put that all into my y equals a f of b of x minus c plus d form of a graph. Maybe it would help to just highlight thought process here. No, actually, the highlighter won't scan anyway. So if you're watching this video, you hopefully just followed those steps along. You can always rewind if you got mixed up here. All right, so that'd be a y value of negative 3f, a value there. Our b value is negative 1. So